What's up, what's up, what's up, what's up? Welcome back. Today we're working on a Linux webcam GUI. So last stream we played around with V4L2 on Linux, which is like the interface that you use to pull frames from a webcam in like a generic way. And we got to the point where we can pull frames okay, but we didn't really get to doing anything with them. So if I like run this thing real quick, and we run for one frame, we export one image, and if I open that image with YUV viewer, you can see there I am. Hello, hello. There's like some like fucked up banding going on here. I don't really know why like there's this like white chunk here, but I could imagine that could be some sort of artifact to do with the first frame. We'll kind of see if it gets a little better as we move on. So I think what I want to do today is we want to take this like loop that we've pulled that is essentially like a port of the like example code from the documentation to Rust. So we have like this little main loop in Rust. And so I think what we want to do is we want to like make this into some sort of like structure that we can use from a UI, and then write a UI that will pull this like device for frames. And just kind of see where that gets us. Hopefully by the end of the stream we have like some sort of visual thing of like a video of the webcam essentially. Yeah, so I think let's just get started. So I think the first thing to do is structify all this shit. So let's make a abstraction around the video camera. I'll call it like V4L2 camera. Maybe we'll call it V4L2 video device. So I think that matches with the like naming of the stuff in the Linux docs and stuff better. We're gonna have some sort of implementation on him. And what's he going to have inside him? The only thing that he really cares about is like a file handle to the video device that we're working with. So we'll call this handle. And I guess this will just be a file for now. When we construct this guy, he's going to make one of himself, and he's going to probably do a bunch of the stuff that we did before. So he's going to open the file handle to the device that we want to use, which means that probably we want the device handle to be a parameter here, or device path, probably. And this is going to be one of those like as ref path, I think is how this thing works, where you have like a key, which is an as ref path, and then we take in the p, so you can take it in as like a string or a path or buffer or whatever. We just double check that's the right syntax. So we can look at maybe like some example in the Rust docs. I'm sure that they have like, yeah, here they have p as ref path. That's what we want. Which means we probably need path, and probably we need as ref as well, which comes from somewhere. Comes from somewhere. std convert as ref. Okay. So we're going to take in this thing. We're going to open it. Here we're going to take in device path here. Boom. And we'll call it handle here instead of video handle. And we probably want to check the capabilities of this guy when we initialize him. Probably we want to do all of this initialization stuff when we create the device. That seems reasonable. Let's do that for now, and if we decide that we want to do something else later, we can change our minds. So call this video handle. And we'll just do all of this shit. All of this. Everything except for the thing in the loop. Okay. Then at the end of this, we can just return v4l2 video device with the handle of video handle. All right. We need fs file here as well for that to be stored in the struct. And yeah, this is it. So we create the video, we open the file, we execute some like Linux ioctls on it to try to get it into the right state. So we assert that his pixel format is this only pixel format that we've tested, which is a interlaced YUV. Then we allocate some buffers for the video device to write stuff into. So we say, hey, we want to use malloc stuff in our memory space, and we are going to put 4 of those guys into, like, just so you know, we have 4 malloc buffers, and then we malloc them from somewhere. We actually probably have to keep track of that stuff. Where are our buffers that we malloced? Because we didn't actually malloc them. We put them in a vector here. So we need to keep track of this guy. So we'll just kind of shove those in here for now so they don't go out of scope. And otherwise, I think it's ready. So here we've basically put all of our memory into the driver. The driver, when we call, when we try to get a frame from it, will write into that memory. We dequeue a buffer, and then when we're done with it, we write it back. So what does like our main loop look like? Maybe we have a like get frame that returns some sort of like smart handle. My idea here is that we want to be able to like get a frame out, and without ever having to like copy it or anything, do what we need to do, and then when it drops, it will like automatically hand itself back to the driver. So the driver will like write into one of these buffers. He goes, oh, now I know that that buffer is in use. I can't use that anymore until you give it back to me. And so we could like immediately copy it out and send that around to wherever we want to send it. But to me, it makes more sense to like make use of like the zero copy nature of the API and just try to work with it that way. So let's say that we come back with a v4l2 frame. And he is going to do basically all the stuff in this loop. So he's going to say, I want to wait for this to be ready. And then I want you to give this stuff to me. Hold on, what is this? This is a buffer. Oh yeah, we run this octal to get the buffer from the driver, and then we do whatever else we want to do with it. Then we put it back. So our guy is going to be like a struct v4l2, what do we call it? v4l2 frame. And in him, he is going to have a buffer, I guess, a v4l2 buffer. v4l2 buffer. Because that's what we're using here. And when we drop this guy, we are going to do something. We are basically just want to do this. ioctl qbuff, which means that we need a file descriptor as well for like the device handle that we're talking to. So we'll just call this a I guess this is where that like borrowed FD thing comes in. So you have like a file handle in Rust, and this gives you like the high level like read write stuff. And under the hood, he's like storing his like Linux file handle as like an integer. And then I've seen this like borrowed FD thing, which says like, hey, I want to like take this from, I want to take like the file descriptor from the file that you're holding, but the lifetimes are tied together. I guess we don't actually need to do that. We can just tie the lifetimes together with our own little thing here. So the file descriptor is going to be an i32. And that means that here we can use self.fd. And then we just use like, I think it's a phantom data. And this allows you to like tie the lifetime of these things together without actually having any data associated with it. So you can say like phantom, and you have like marker phantom data. And then here you put in a phantom data. And this basically says like, hey, we are using the like, whatever you tie the lifetime of this thing to, we are the same, I guess. So like if this guy returns, if like I return a v4l2, sorry, if I create this guy with a lifetime that's the same as my v4l2 video device lifetime, then those will be like tied together, and this won't be able to like be, the device won't be able to like go to scope while this is still in use, I guess. How do I put a little, I have to do it like this. Like this. Yeah. Okay. We have to now pass lifetimes in everywhere. Okay. And this needs to be like this. No fields v4l2 buff, so this is buff like this. And all this is going to unsafe, because we're interacting with the outside world. Okay. So now we just have to handle the part where we get the thing. And we just do all of this stuff. Boom. Copy. Paste. Okay. So here we poll for the thing. Unsafe. Put all this in an unsafe block. And then we just have to return the frame that we got. So here we need to see let fd is equal to self dot, is it handle, is what we called it? Handle as raw fd. Then we need to return the frame. So say v4l2 frame. I think that if we just put a automatic lifetime on here, it will say, hey, what is like a reference in my function signature self? And it's like, that's the only thing that I could be a reference to, so I'm going to use that. So we pass in the file descriptor here. The buff is a v4l2 buff. And then the phantom data is a just phantom data, like this. Boom. Okay. So I think that now we can like nuke the main function, and we can say let device is v4l2 video device new with device name. It doesn't like that for some reason. Because it doesn't have a size known at compile time. Do I have to ampersand this? Yeah, I do. Okay. And then we can just say loop or device get frame. Oh, I actually didn't want to nuke everything because I needed to copy paste this stuff where we write out the frame to a file. Okay. So we can say device get frame, and we just call this v4l2 buff, or we call this frame, I guess. And now we need an API to like extract the data from the frame. So here we'll say impl v4l2 frame, who is associated with some unknown lifetime. Can you just unname this actually? Can you do it like this? You might be able to. You might be able to. Unnamed lifetime, please. Let's comment this stuff out so we can see we still compile. Sick. And then we're going to say, like, data, I guess. So he's going to take himself, and he's going to return a U8 slice, I guess. That seems reasonable. And then we're just going to do this shit. So we say, hey, from raw parts, we have a pointer, and we have a length. So just turn that into a slice, please. All right. So then we can say here we write frame data. And hopefully all of that turns into something that works okay, which I think it did. Yep, that looks like me. And then if I like move my arms around so that we have like a new... Yeah, okay. Looks like everything is still working. So we have now this like structure that we should be able to use from within a GUI, which is nice. Let's fix this warning. Buffs is never used. Yeah, I get it. I get it. So here we just say now buffs. Wrong way around. Underscore buffs is from a non-underscore buffs. Perfect. Okay. And then probably all of this stuff should go in the v4l2 module, which makes sense to me. So this is public. This is public. This is public. This is public. And this is public. Okay. Which means here in the v4l2 module, we need to take all of our like sys binding stuff and put them in a module so that maybe we don't, but this seems reasonable to me. And then we'll just cut and paste all of this shit out like this. The octal as well has to come out. Womp womp. All right. So now we go into here, we paste. And we just go in here, and everywhere we said v4l2 colon, we just replace it with sys colon. Okay. And we copy paste our imports as well. And it looks like we're probably chilling. So then here we have v4l2 video device like this. And everything's looking compiles. We're good. Nice. Nice. We're chilling. Okay. Let's just fix some of these imports up a little bit. And git add -u, git commit -m, refactor to class. Cool. So now what we want to do is we want to like hook that up to a UI of some sort. So my go-to for this is this like Rust library eGUI. It's pretty sick. It's like an immediate mode GUI written in Rust where things just, they feel easy to use to me. Then they have this like wrapper thing, eFrame, I think is what it's called. And this is like, you implement a trait for some application, and using that trait, all you have to do is implement like an update thing, and I think it just like runs pretty simply there. So we can try that. We can try basically copy pasting this here for our GUI, and we'll call this what, like webcam UI or something. We'll call it webcam UI. We need to add eFrame. And then we need to run their like main loop. Boom. And for now, we won't worry about any of the webcam stuff. We just want to see if their like hello world works. Or if we need to do some like environment shit to get it to work correctly. You gotta give it a sec. Sup? Welcome. Oh. Dude, what's it doing? What is it doing? He's working hard. It's just, holy shit. 300 dependencies is so many. That's crazy. I guess there's a lot of stuff that goes into UI. Makes sense. What is this? Like OpenGL, Futures, Wayland, X11. Sure. Sure. Okay. My eGUI app, not defined. We called it webcam UI. We didn't use eFrame, eGUI. Anything else? Nope. Looks like it should run now. And let's hope that it doesn't like fucking crash in some way. Did we not run it? Is this fucking failing? Probably is. It's probably failing. We're probably missing some environment shit. Yeah, he's winit, event loop, Wayland, no Wayland lib. Can we just do like Wayland display equals just to, like force into the X11 path? Ugh. Onset Wayland display. Ugh. Okay. I think we hit this before, and I think all we had to do was add some like chunks of libraries to our environment, and I think we did that in this guy. So we can just kind of yoinkies this thing, this list of input, this list of libraries, and just hope that one of these guys solves it, because I don't really want to go through this work again. So probably we're looking at this shit. This stuff's probably all the GUI related stuff. Let's give it a quick shot. Hopefully. We'll cross our fingers. Cargo run. Come on, give it to me. Fuck off, man. No Wayland lib? Oh, maybe this needs to go into build inputs, because they're like runtime dependencies as well as build time dependencies. Fine. What do you mean no such job? Fine, I'll add a semicolon. God. He's such a whiner sometimes. Compilers and their syntax. What bitches. Alright. Cargo run. Why? I wonder why it's deciding that it needs to rerun all of the build every time I reset my environment. Are you fucking kidding me? No Wayland lib? What did I do in this other project? What did I do? Oh, we did this as well. that would do it. Where we just basically like injected a bunch of shit into our library paths because Nix wasn't doing it for us and we couldn't really figure out why, I guess. This is the one. I think the rest of this doesn't matter. Bindgen, libclang. Yeah, the rest of this is not important. This time, please. Please. Come on, buddy. There we go. Okay, we're up. We're up and running. So we've got our little Hello World eGUI application. And now we can start actually making something. Okay, so what do we want to do? We have a panel here, and we want to just, essentially for now, I guess, put an image in it. And that image is going to be the one that we pull from the video device. So I think that they have like an image thing that we could use in here, maybe. Do they support? We have like a YUV interlaced image. So I guess that kind of depends on if they support it. So this kind of expects me to have like a normal picture, I guess. Like that is like PNG encoded or something. See crate load for more. Ah, here we go. Here we go. Image loader. Decode the bytes into an array of colors. load the raw bytes of an image. Okay. So image loader, we load a thing from a URI. And this isn't really what I want. This isn't really what I want. Let's see. Okay, so if we ask it to display like an image or a texture, is that what they want? Like, is image the thing? Is that the abstraction I'm looking for? UI, let's see, image. It does look like that's what they want. Into image source. Maybe texture makes more sense. Load the image from an existing texture. How do they know the format? Sized texture. Are they just expecting RGB no matter what? They might be. They might be. This is used by image new. Image into image source. Okay, and UI image into image source. Then they have like include image where they pass in a PNG. Gross. None of this is like... It's almost like too high level for what I want. I just want to give it like a bucket of bytes and let it use it. But I guess it must be just expecting RGB based off this API. I don't see what else it could be. Like, this makes sense to me. They are just saying like, hey, we'll decode a PNG for you if you want. Bytes. Oh, here, this should give us a clue. So bytes is something that is just a bunch of U8s. And they're saying, yeah, so they're saying that like you take a JPEG, you stick it in memory, and they'll handle the decoding for you. So I wonder what they do. They do context try load texture. Try load texture. Okay, so they look at texture loaders and try to run any of them. I see. So that, I think we saw documentation on that somewhere. Loader. Ah, I see. So maybe we can inject a loader that will work for our specific texture or something. Yeah, I see. If you just want to display some images, eGUI extras will get you up and running quickly with some reasonable reasonable default implementations. What does this guy provide us? Image. Image. Oh, fuck. Install image loaders. Yeah, file loader, we'll try to load this, blah, blah, blah. Might be interested in this from GitHub. Interesting. I'll give it a look. GitHub.com/this. How to update a texture. Yeah, I'm more worried about like what the texture itself expects. We'll get to the dynamically updating later. I'm just more trying to figure out like, how do I show anything? You know? What it does look like, probably, I almost want to, how do I say this? Like, bypass all of this. Oh, here we go. Color image. Pixels of color 32. Yeah. Okay. This is getting spicy. So where does the color image come from? Where does Load image from memory. Here we go. Here we go. So if we can go from RGBA, we get this thing, and then presumably we can display a color image somewhere. This is starting to make sense. Do they have like some sort of like into? Let's see. Who uses this thing? Was it just the image loader? Decodes raw bytes into a color image. A texture loader uploads a color image to the GPU. So probably we create a color image and then we call like try load texture or something. And I just want something that takes in a color image. God damn it. Why is this so hard? So somewhere we should be able to feed in a color image and get a texture. But maybe we have to go through their like fucking pipeline. I feel like I'm missing something. Because I don't really want to go through all of their thing. Nice link, thank you. Load texture. So they come from image, which goes into image data. And image data could be a color image. Perfect. This is what I was missing. Sweet, okay. All of that makes sense. So what we have to do, I guess, is convert our YU, into a bunch of color 32s. So here, not here. Yeah, on update, I guess. For now, let's just do everything kind of serially. We won't worry about like GUI responsiveness or anything, because I don't want to deal with that yet. Our UI will hold onto a v4l2 device, and he's going to be a v4l2 video device. When we construct this guy, we're just going to do this. We can't drive default anymore. We are going to construct our device. And then we're going to say webcam UI has a device that is a v4l2 device, like this. Boom. And you could even name this properly, like this, and then you don't have to repeat the name. Cool. And then on update, we're going to get a frame, which is going to block, and that's okay. We're going to just live with that for now. And our frame is going to get data that is YUYV encoded. So let data is equal this. And now, what we could do for now is ignore U and V. And if we ignore all color information, converting this to RGB should be pretty fucking easy. So you should be able to say like data dot iter, sure. There's probably some iterator method to like skip every nth item. So if I want like every other one, there's probably some API for that. Iterator in Rust. One of these step by. This looks like starting at the same point, but stepping by the given amount each iteration. Yes, they get 0, 2, 4. Perfect. Perfect. So we say step by 2. So discard U and V data. Okay. And then we just map each Y to a color 32. So we can say eGUI color 32 from RGB, and we just do Y, Y, Y. Boom. Boom. And here we are going to put in, this is going to be the like color data. Okay. And we should probably also get the width and height from this guy. So pub function width is going to return a what, like usize, and height is going to be the same. You should make a list of all the projects you've made so far. I should do that at least for myself, because that'll be very useful when I'm writing a resume when I have to go back to work. But you're right that it's probably interesting for y'all as well. Surely this guy has a width and height field on him. Does he not? v4l2 buffer. Really? This doesn't have... Oh, maybe this M field? Wow, I thought for sure he did. Where... I guess we just get the width and height. We, like, set it initially. So I guess for now, we're going to just say, like, fix me get from actual device. But we know that it's this stuff down here, which we print when we run. And I think it's 640 by 40, I think. 640. I think it's 640 by 40. But we can hide that from now, and then not worry about it. Okay. Consider dereferencing the borrow. Can I say, like, ref here so that I don't have to? No. That makes it worse. That makes it a double bot reference instead of a single reference. We'll just do this. And then we need to collect this into a vector. Like this. Boom. Oops, this should be a vec color 32. Okay, and then we say what? Let image is equal to color image and what was he again? I already forgot. Color image has a size and pixels, and we just make him from a new with the size of frame width and frame height and data, color data. Easy. And then we should be able to, I guess we need eGUI color 32 as well. In here for that error to go away. What is he complaining about now? Expected struct eFrame eGUI color 32. Hold on. Oh, I see. This is the wrong function. This creates a filled image. I guess we just make it from ourselves then. We say like this. Pixels like this and size like this. Cool. Okay, and then we had a load textures function. So here, allocate a texture. This is for advanced users. Most people should call this instead. This isn't what I want, because this takes in a URI. I guess I'm an advanced user, bumbling around like an idiot. Advanced. You must convert it into texture using this function. This function will hand over image data to the eGUI backend, which will upload to the GPU. Make sure to call this once per image, not in your main GUI code. This call is not immediate safe. The given name can be useful for later debugging. Okay. Sure. So that's pretty funny. they're like, this code is not immediate safe, but then also in their example, they are doing it like within the immediate mode section. So I guess they're kind of claiming we're only doing it once, so it's probably okay for the GUI to lag one time, but it is still kind of funny. So for now, I'm going to ignore that warning and do it here. And then eventually probably what will happen is I'll probably have a thread that's polling for new frames and we'll create these textures over there, and should probably also deallocate textures. Does it automatically handle that? Like if I drop a texture, does it automatically? Yeah, okay, sweet. I don't need to worry about like memory management and all that stuff. Yo, what's up? Okay, so let's just say let texture is equal to ctx load texture, and we give it a name, which is image. Sure, fuck it. And the image is image. Cool. And the options are texture options. And what are the texture options? Magnification, minification. Can I just say, oh, we can just use texture options. And I guess it's like interpolation, linear or nearest. Linear seems reasonable. Fuck it. This comes from eGUI, so we need eGUI texture options like this, and then we could probably just show the texture. Right? That's kind of what this said. UI. Here we can do UI image texture ID and texture size vec2. Remove the extra argument. What extra argument? I guess they just... oh, I see. They put this in a tuple. This will automatically cast or something. Yeah, I see. All right, moment of truth. Let's see it. So if everything is right... Ooh, look at that. Okay. That's not bad. I mean, it's lagging a little bit. But probably because of the fact that where it's like, that's not fucking text. This is not immediate mode GUI safe. I wonder why it's like freezing so much. Oh, we're hitting that shit where if my mouse isn't moving over top of the thing, then eGUI thinks that it doesn't have to do anything. So it goes like, oh, I'll be smart and I just won't run my update loop. Because it thinks that like a user has to interact with the UI for that to make sense. Okay. Sure. That doesn't look none of this looks like too awful. Okay. So next step is probably let's split this up actually. So instead of the UI owning the V4L2 device, what should probably be happening is we should probably have a thread that is polling for webcam frames, converting them into the format that eGUI wants, and then handling that. That seems reasonable. And if we really wanted to get like fancy, probably what we should do is we should have like actually no, it's fine. That's good enough. Okay. So we did this, and we'll call it black and white only. I don't know when we did it, but we did it. And now we're going to say split out thread to feed images. Okay. And this will solve two of those problems at once. That will solve the fact that I have to wiggle my mouse over the camera, over the UI, because that thread can just say, hey, eGUI, I'm ready to draw again. Please fucking draw again. And it will solve the fact that we're not supposed to call this from within our like main loop. So what? We can say we have some sort of like GUI feeder thread, right? And he is going to now be the owner of this V4L2 device. Boom. And I guess maybe we don't even need him to be a structure. Maybe we just have like function GUI feed GUI. And what does he take in? He takes in the device. Like this. And he probably also takes in like a writer. Somewhere to send the frames. So we're gonna call this like a sender, which is gonna use std sync mpsc send. We're gonna need sender and receiver, certainly. So he's gonna say be a sender of texture. Is that what this guy is? What is this load texture return? Texture handle. Okay. And he is going to run forever. There's going to be a little loop. And he is going to try to pull a frame. He's basically going to do this. All of this stuff. Read the frame. Get the data. Convert it. Load the texture. And then send the texture. That's it. He also needs a eGUI context. So we're going to say this is an eGUI context. Okay. And how do we like extract that context out? Where does it come from? So I guess everything comes from eframe run native. Is that right? Eframe. So it looks like we can't actually like pull the context out easily because the thing isn't like constructed until we enter this like main loop from eGUI. This is how you write a native app. App creator. Yeah, okay. Sure. Okay. So how do we... I guess we can spin up the thread when we create, I guess. So we can say let tx rx is equal to mpsc channel. Okay. Our webcam UI, instead of holding the V for L2 devices, now it's just going to hold a receiver of frames. Like, what is this? Receiver of texture handle. Okay. And I guess maybe we should be updating the texture instead of recreating, like making a new one every time. I don't know if that's like a lot or a lot more expensive. I guess we'll just do this for now though. Fuck it. Fuck it. Okay. And then we just spawn a thread. What the hell? He doesn't like receiver here. Did I spell receiver wrong? R-E-C-E... Really? E-V-I-E-R? That's not how I would have spelled it. Receiver. I would have put the I in the wrong spot for sure. This looks fucking wrong. Am I high? Receiver. Yeah, the I's on the left of the V. Why are they putting it on the right here? Did I just misspell it once and it hasn't picked that up yet? Yeah, okay. I just typoed it up here and no one cares? Weird. Okay. I thought that it would have been like, that doesn't exist. There we go. There we go. Okay. So then we just have to feed GUI. So we say what? std thread spawn with move here, and we just say feed GUI with the can we get the regular context over here? cc.eGUI context. Nice. We probably have to clone it here. So we get the context. We have our device. So we say ctx v4l2 device. What else did we put in here? And the sender. Cool. Cool. So now in our update loop, instead of doing all this, we just say, I guess we have to cache the last texture just in case. So here we say last texture is an option of texture handle. Okay. And then on each frame we say, is there a new thing available? So we say self.rx try receive. And we say while let OK v is equal to this, then we say that our texture handle can be updated. So we can say self last texture is equal to some v, like this. Otherwise, we're done. Okay. Then if let sum texture is equal to self.last texture, like this, then we can just do this. Boom. And last texture starts as none, because it's not there yet, and then we're chilling. And then the last thing we have to do here is after we send, we have to wake up. So there's some way to tell it to redraw. Wake up. Redraw. Surely there's just a method on context that we can call. Oh, repaint maybe sounds familiar. Request repaint. Here we go. Cool. Cool. So now, if I run this, I think that we should be seeing updates come, yeah, even without me moving the mouse. And things are moving. There's no more lag happening. Looking good. I wonder if we see like any like leaks or anything. No, we do see like 50% CPU usage, which is pretty high. I wonder if we can like, if that goes down in release mode. Let's just kind of wait a year for all of that to build again. And then probably the next thing we want to do is like fix black and white. So probably we want to say convert YUV to RGB correctly. And while this is compiling, we can start Googling that. YUV to RGB. What is the formula? Great. Where does this come from? YUV to RGB Wikipedia. Oh yeah, here we go. I don't even really know what it is. Is this like example of UV color plane? Y value 0.5. So, okay, sure. I don't really understand, but okay. And are these the formulas that we were seeing in this thing here? 16, 128, 128, 1.164. Like, those don't match up anything on here. YCBCR was appropriate, so I wrote code for these two transformations. 1 part 256, blah, blah, blah. Oh, hey. It finally built. It started. So now is it like... Oh yeah, CPU usage of this thing is way lower. Down to 6% from 50. Alright, I'll take it. I'll take it. Probably, if I had to guess, that means that a lot of the time was spent probably on that color conversion. So probably in release mode, that iteration of like Ys to RGBs is like way fucking faster. Just my guess. Okay. I guess. So when we are... If we have interlaced YUV, I guess we have to look ahead for the next U and the next V every time we do some sort of like color conversion. So hold on. So if we have like YU, YV, YU, YV. For this first pixel, we need to get the V from all the way over here to know what the correct color value is. So you almost have like, you almost want to like take your, and maybe the UV should be applied to both of these pixels. So if we're iterating on our conversion and we're saying we're taking every other Y, we almost want to duplicate this. Yeah. So we're going to say our Ys are skip or take every other. Our U's are going to be take every fourth and duplicate, right? Because like if we're going to go Y, U, Y, V, we need 2 U's for this section. So this is going to turn into Y, Y, U, U, V, V. So we need to extract the U, then double it. I think that makes sense. We can probably do that with like some iterator shit. So we could say let Y's is equal to data iter skip by step by 2. Okay. Let U is equal to data iter skip 1 step by 4. Repeat. We want to like repeat each element in these twice to get the same number of elements. So how do I like rust iter repeat? Creates a new iterator that endlessly repeats a single element. That's not really what I want. I want something that like interlaces each item. Intersperse. Copy of separator. That's not what I want. That's not what I want. There's no like duplicate my element, because that would make it just really, really convenient to work with. Array chunks. Any. We could like write our own iterator that does it. I just kind of thought there would be one. Rust iterator repeat each element. Here we go. This is what I'm looking for. Oh, that's kind of clever. That's clever. So they say, hey, for each element, we'll generate a new iterator that is that thing repeated. Yeah, okay. So then they're going to say flat, what? Flat map U SED iter repeat. Repeat U take 2. Okay, and then we do the same for V's. Okay. And then we should be able to say let YUVs is equal to Ys.zip use. Do I have to like do it like this, .zip V's, and have this like fucking weird ass iterator? Could be. So we have Y U V like this, I think. And we have to map this into a color 32. Which they're claiming on the internet is this formula here. So we can just copy paste this. Copy paste. Okay. This is the wrong way. RGB from YUV. Oh no, this is right. And are these in the range of 0 to 1? What are the like, are these guys working with like normalized values? Certainly not, because they're doing like divisions by 256 and shit. So this sounds about right. So let, first of all, these guys should be all lowercase. This should be y, u, v. These guys all needs like let's in front of them. And we'll say y minus here, u minus here, and v minus here. Okay. And then all of these guys need to be turned into floats. As if they do. Cool. And then we should be able to say GUI from color 32 RGB. But these guys need to be cast back into U and dates probably. G as U8, B as U8. And I have no idea if this is right at all, but we'll find out really quick. Color data back color 32 should be this. So this would be a collect at the end. Collect, like this, boom. All right, who knows if that's right? But we'll find out. Perfect. I see no problem. So what's interesting there is the color of my sweater is actually pretty correct. Everything else is just like totally fucked, right? Keep that. It's actually like pretty funny. Yeah, I'm actually not that against it. Okay, so let's print line what we have in here. RGB is RGB. Okay. Okay, so those are big ass numbers, right? Like 500, like what the fuck? So that kind of makes me think that this is wrong. Probably this is fucking up, would be my guess. This like U minus 128, that's overflowing almost certainly. So maybe we should do, we've got these like as F32s in the wrong spot. Maybe it should be like this. Could be. Could be. And these guys have to go away. Dereference. Alright. Could be. Could be. Could also not be. Oh! So now it's slow as shit. Also, everything's green. I'm the Hulk now. Which also doesn't seem right. But we don't have any of those like artifacts anymore, and everything's like kind of in a reasonable brightness range now, which is kind of making sense. It's possible that I got U and V swapped. So can I just put U and V like this? We can just swap them like this, I guess. It's weird that swapping U and V had, like, almost no noticeable effect. U, V. Let's check our iterator bullshit. So let's collect all of these guys, actually. Instead of doing this, let's just say, let y's equal y's len. U's is u's len, and v's is v's len. And we can print line how many of each you got. Because there's a good chance that we fucked that up. What? No method length found for struct flat map? Why the fuck not? That's strange. Why not? Why not? Len rust. That's not going to be useful. Iterator? I thought iterators had length fields on them. Oh, maybe I have to actually just iterate the whole thing. Okay, fine. Function get length of iterator is iterator. And we take in the iterator. And we return a usize. And we just say, let ret is equal to 0 first. And while let something is equal to it next, ret plus equals 1, return ret. Okay. Then we can say get len y's. And we get len of u's and v's. Okay. So they are all matching length. So it seems like I didn't really like heavily fuck up there. Oh, u and v are the same. Oops, I forgot to skip 3 to start with v's. There it is. There it is. Okay, let's try this again. So that explains why swapping u and v also had no effect, is because they were just both u. That explains a lot. Hey, look at that. That's skin color. Hell yeah. Hell yeah. It's pretty cool. Pretty cool. Okay. So, yeah, not bad, not bad. I'm curious if, still a little bit, if I should be updating those textures every time instead of creating new ones, but seems fine. Seems fine. I guess the next thing to do would be to start looking at, like, configuration. So, right now, we're kind of just opening up the device, and we're just assuming that it's going to be in this like YUV interlaced mode, which is not really true. So we should probably start looking at like, well, what options are there and can we like set them? So let's start looking at that to some extent. So I think I saw, well, maybe first we should kill some of this, get rid of that debug code. Get rid of some of these silly comments. Get rid of this. I guess everything else is fine. Everything else is fine. Nothing to worry about here. Okay. Cargo check. Yeah, okay, we're chilling. Maybe we'll checkpoint. And we'll say, webcam working. Sure. Sure. So I think somewhere I saw there's a way to like enumerate v4l2 enumerate. Oh, hold on. Before we do that, I lied. We should fucking fix the hard-coded 640 by 480. That's an obvious problem. So here, these 640 by 480, obviously fucking broken. And I want to just look at what my options are. So we'll say fix hard-coded image size. Will we be using this in future streams? I don't know. I haven't decided. I was kind of considering looking at attaching this to the like image to text thing. It'd be kind of funny if like my video camera was just the like was ASCII. But I haven't really decided if that's actually going to look okay or worth doing. So maybe. That's why I wanted to look into it, but we might just leave it up to the professionals at OBS, you know? What was I looking for? I was looking at V4L2 DQ frame. ASCII for you. Yeah, perfect. So what do we do somewhere? Somewhere we DQ buffer. This guy. So let's look at this. So the struct v4l2 buffer, we say, hey, this is a type, index, timestamp, sequence. Yeah, none of this really seems to say the width and height. Struct of v4l2 plane. Does this guy have a width and height? No. So I guess maybe we're supposed to know what configuration we're in up front. Because we ask for the current format, and then we set the, yeah, okay. So I guess, does it make more sense for the width and height not to be associated with the frame? No, I think the width and height being held by the frame makes a lot of sense. So I think that we can just duplicate that information. So we'll say width usize, height usize, and we'll take in we'll just return self width and self height. That seems fine. A little bit of extra metadata never hurt anybody. And then when we create this guy, we just have to remember. So probably, I guess, since we don't support any configuration right now, we can also just hold that in the device. And we'll just have to update this if we support changing formats later. So width here is format, what is it? Format picks width. Format picks width. And height is format picks height. And what is he complaining about? Format, oh, it's FMT. Like this. And here we can say as usize, like this, boom. Easy. And then we duplicate those over here. Width, self.width. And height is self.height. Okay. Cool. This is unsafe, so I guess we just kind of wrap this in with the previous unsafe block. Fuck it. And then we're chilling there. Cargo run, I guess, just to make sure that nothing's broken. Just to make sure. Yep, we're chilling. We are chilling. So we can call that done. And now we can look at configuration. So we can commit -m checkpoint width and height no longer hard-coded. Okay. So let's see. I saw somewhere that there's a way to enumerate formats, which is probably what we're going to want to look at. Necessary cookies only, please. This, okay, so yeah, sure, you can run v4l2 control list formats, but they must be doing something under the hood. You can also see C++ code to get the formats. Okay. Okay, this is all I was looking for. Vid IOC enum format. Vid IOC enum format. There's got to be docs on that somewhere. To enumerate image formats, applications initialize the type and index field of the format description call and call this ioctl with a pointer to this structure. Okay, sure. So let's, on this device, make a function print formats for now. Later this will turn into something that returns formats, but for now we just want to print them so that we have something to see. And probably here we should say that we are working on this. So we print the formats, and we can say, what do they say we want? A v4l2 format disk. Sys let desk is equal to sys v4l2 format description. Okay. So we have an index field as well, which means that somewhere they must tell us how many we could possibly get. Drivers fill the rest of the structure. All formats are enumerable by beginning at index 0 and incrementing until e and val is returned. Oh, okay. Sure. So we say we do this in a loop. And this guy is going to be one of these. We're going to zero him out. This almost certainly is all going to be in like an unsafe block of some sort. And so we set the type. Should be whenever we set type 2 on all these other ones, probably. Buff type video capture. No, not buff type. Not cap. So what do they want? Number of the format in the enumeration set by application. This is in no way related to the pixel format field. No, okay, type. Oh, here we go. V4L2 buff. V4L2 buff type video capture. This is what I'm looking for. So this is equal to this. Okay. And the index is going to be where we're at in the loop. So here we do this. Desk index is equal to I. Okay. And then at the end of this, we do I plus equals 1. And we are going to request the format. Hey, Linky, thanks for the prime. Appreciate it. Okay. So here we're going to call our octal on the file descriptor. So we're going to say let fd equals self dot video handle as raw fd. We're going to call an octal on this guy with sys v4l2 vid IOC, sorry. Vid IOC enum format. And then we're going to pass in the descriptor here. So as mutable descriptor. He doesn't like that this vid IOC enum format doesn't exist because the way that the macros are resolved in our like C bindings generator, it just doesn't follow these like macro calls. So what we did last stream was we added this like C program that basically creates Rust constants based off of whatever we put in here. So we can say vid IOC enum format. And this will... I hooked this up to the build system off stream. So hopefully if I just cargo run this again, that will like resolve, which it looks like it does, which is pretty cool. And so now we can just go back here and he's happy. He's chilling. We have to unwrap this guy because he might fail. And then I guess we just print the format. Print line. Description. And then just on construction, I guess, we will call, where we make this guy, v4l2 device, print formats. And then probably this is good. Oh, this is a private method. Fine. We'll write pub in front of it. Chill. Okay. So he doesn't like that because we forgot that we were going to check if we were ever at enval. So get, was it print formats? We had to say, let ret is equal to this. And here we can just say, if let e is equal to ret, what is our error type here? It's a IO error. So in Rust, how do we check if this is e in val? Is it like .kind or something on this thing? Yeah, we have error kind. So we get the kind, and the kind is going to be invalid. And it's probably going to be invalid. I don't know if invalid input or invalid data. Probably invalid input. Let's maybe just print line the error. Be kind. And that will tell us. Oh, shit. Invalid input. Perfect. So we can say if let e if e.kind is equal to std io error kind invalid input, we break. Otherwise, we panic and say unexpected error e. Okay. I think that's chillin'. Cool. So here we see 2 format descriptions. That's it? I don't think that's what I saw in OBS. Because, like, I'm pretty sure that there were, like, different resolutions and stuff. Maybe we get to specify. Let's look at that get format call again. Format description. Description of the format with a null terminating string. And the pixel format identifier. So maybe this doesn't specify how large the like width and height of the image. So before we do specifically ask it to be 640 by 480 when we call set format, which is interesting. Can we look at that? Maybe. After switching input or output, the list of enumerated image formats may be different. Sure, that makes sense. Can we like function reference? Oh, here we go. Enum. There's a bunch of like enum things we can do. Enumerate frame sizes. i.e. width and height in pixels that the device supports for the given pixel format. Perfect, perfect, perfect. Okay, that makes sense. So for each, so the formats are probably just like the color space we support, like either whether we're like the MJPEG version or the YUV version is probably what we were seeing. So it would be nice if we could how do we want to do this? We have all of these pix format defines already. What would be kind of nifty is if we could convert these to strings. I wonder if that's possible. I wonder how hard those. So you say like function pixel format to string, and we take in the format, and we output a string. Maybe a static string. We paste all these guys. And we go through here. And we delete these words. We don't need these. Maybe what makes more sense is to do this as a macro. Yeah, so you delete word, find this thing, delete. And we do this like 100 times. How many more? 138 to 260. So like 130, 120. Okay. So now we have all of our pixel formats here as like things. Variables, we want to slap a like sys in front of them. And then we say match format. And if we get any of these, or something. If we get anything else, we say unknown. Okay. And then just for each of these guys, we just have to run a macro that says this thing goes to this thing as a string. Okay, and then we just run this how many times? 260 times. 260 at Q. Come on, baby. Oh, my editor's fucking fried. What's happened? Oh, we're okay. I guess maybe doing it 200 times at once was too much. Maybe we have to do it in smaller batches. 20? How many are left here? We'll just run it manually for the rest. Okay. Wow. So it does look like that actually worked, which is kind of nifty. So now we can like look at what the pixel format for each of these is and print it out. So when we print formats, we could then say desk, is it pixel format? I already forgot. This is a format desk. We can just leave this. It's pixel format, no underscore. Print line. And we say pixel format to string this guy. Okay, boom. Chillin'. Pixel format to... foramped. Format. Perfect. So now when we run this guy, we should maybe see... Sick. Okay, so we see that there's one YUYV and one JPEG. Cool. I guess, do we even want to support more than one of these? Probably not. Probably not. Because, like, the only thing that we have, like, code that is expecting YUYV right now. So maybe that's fine. And so maybe instead what we do is we enumerate the frame sizes. So if desk.pixel format is equal to sys, what is it? This guy. If this is our pixel format, I guess if it's not this, we just continue. We don't give a fuck. Otherwise, we want to enumerate the sizes that are available for this. I assume that they're like frame rates as well. Maybe? Or maybe frame rates are just done in OBS by like skipping every n frames or something. But I assume this. So we look at the pixel formats. Okay. We did that already. Then we say, what are the frame sizes? That returns an index in pixel format and receives a frame width and height. So I guess we do the same shit where we enumerate until we have run out of indexes. So this is, we should rename I here to be like format index. And then we do the same thing for pixel index. So we just do another loop here. And I guess this is getting to the point where we should maybe be splitting out a new function. So you can say what? Function print what is this called? Frame sizes for format. And we get a format in as a usize, U32. What are these things again? U32s. And we just do the same loop, I guess. We need the file descriptor as well. So here we have file descriptor i32, and then we just run this loop. Almost the same loop. So I'm just gonna copy paste it. And instead of format index, we'll rename this back to I. We don't need to extract the file descriptor. And this is no longer format description. This is firm size enum. We need to specify the correct, what was it? Type and index? Type field. Yeah. So this guy has index, pixel format, type. So I guess we give it type, index, and now pixel format is format. And then instead of enum format, we enum frame sizes. He doesn't like that, not pixel format. Pixel, oh, this time it's pixel underscore format, of course. Sometimes there's no underscore, sometimes there is. We need to add this enum frame sizes to our list of supported things. Our supported ioctals. Then here, I guess instead of printing this, we just print out the width and height, probably. Oh, we have discrete, stepwise, and firm size enum. What the fuck? So the function returns success if the given index value is valid. The application should increase the index by one or more each call. Where does this like discrete come from? When the application calls a function with index 0, it must check the type field to determine the type of the frame size enumeration the device supports. Only for... Oh. I see. So we don't set type here. We don't set type. We hope to God that we're getting discrete. I think. So here we'll say if desk.type is not equal to this, we panic, only know how to handle discrete frame sizes. We'll start with 1. Fuck. Here's another one of those like gen ioctal things that we need. So this is print define u probably. Cargo run. And it's pixel underscore format now. Again, where did I write 284? Oh, oops. Okay. And then here we can just print line the description, I guess, for now. Just to see. Cargo run. He doesn't like that because he actually can't be formatted that way. Because probably he's got like a union type inside and Rust doesn't like that. Yeah, okay. We'll just assume that it's discrete for now. We will assume. Desk dot... What's the thing in here? Union. What is the fucking... Am I high? This is... Oh, it's just bindgen anon 1? What a fucking awful name. Where does this come from? Is this just like some like bindgen bullshit? What does this like struct look like in... Oh, yeah, okay. So in C, this is like an anonymous union so that you can just like refer to the fields directly. But in Rust, it doesn't fucking like that. Can I name this field? Because I think it's bullshit to have to type bindgen anon1 here. Like, that seems brittle. But for now, fuck it. Fuck it. Okay, so it didn't print shit because we never call this function. That makes sense. So here we just want to say print frame size for format. Where was I? Oh god, I got lost. I'm lost. Print frame sizes for format. And then we pass in the file descriptor, the pixel format, and that's it. Okay, so we got a bunch of discrete frame sizes, 640 by 480, 1280 by 720, 960 by 544. So that seems reasonable. And then we go, oh shit, we got something that is non-discrete. So that's kind of interesting. Can we like, probably because we should actually first check if we failed first. Maybe this camera only supports discrete frame sizes, but then failed. Yeah, okay, we're chilling. We're chilling. So we only have discrete frame sizes, and they are reasonable numbers. And so maybe what we could do is we could like expose those somehow to the UI. So maybe here what we do is we can say pub function get sizes, get frame sizes. And this is gonna return like a vector of U32 by U32, I guess. Here we're going to assume that our video format is always going to be format YUIV because it's the only thing we support right now. So we don't need to do this like enumeration of formats. We know that it's YUIV. And so all we actually need to do is this stuff here. And instead of printing, we'll push them into a vector here. So format now is just hard-coded to sys... fuck, I lost it. YUIV, this guy. So this is just going to be hard-coded like this. Boom, boom. We need our file descriptor. So self.file as raw fd, and this is actually called something like video handle, I think. Okay. Here, oh, it's handle, not video handle. Here we have a return, which is a vector. And at the end, we just say ret. Okay. And then instead of printing it, we just say ret.push desk. I guess we say let width is equal to desk bind gen anon 1 discrete width. Height is this. And we just say ret.push width height. What? No, oh, because we rebound ret. Fuck off. This guy is going to be called ioctal ret, I guess. Cool. Cool. And now we can get the frame sizes, and we need a way to like set. How do we want to do this? Pub function set frame size, and he's going to do something. I don't really know what yet. Maybe, and what is he going to take in? Maybe he's going to take in like the index. That seems kind of nice. Because then there's like no way for us to like pass in invalid widths and heights. We have to pass in like which one of these things that we got are we going to set back. And then we can say then we have to set the pixel format somewhere. I think that's what we did last time. S format, maybe? Yeah. Okay, sure. So we get the format that we have right now, replace width and height with the thing that we retrieved. Sure, yeah, that seems reasonable. So we say what? First of all, we have this G format somewhere? So we have some code that's similar. So here we say that this is our format. Okay. We have our type. Great. Now we want to set the width and the height. Is based off of what they gave us. So I guess we can do something crazy. We can say like let width height is equal to self get frame sizes IDX. And we should validate, we should like fail if IDX is out of bounds. But instead we'll just fucking crash the program because I don't give a shit right now. Then we can say format pix width is equal to width. Format pix height is equal to height. And probably we should actually fill the other fields with what we get from the when we call get format. So I think it actually makes sense to do it this way. We can say let fd is equal to self dot handle as raw fd. We populate this structure with what it currently is, reset the width and height, and then just call set. S format mute format. And then the last piece here is that we have to reset our width and height that we've cached to be updated to the new one. Okay. I guess these are probably as you size here, like this. Cool. And this constant needs to be defined, so we go back into our gen ioctals and look for G format and just slap an S in here instead. Boom. Boom, boom, boom. We're close. I need to specify that this requires a mutable reference to self. Okay. Cool. And now where this gets a little hairy is how do we actually interact with this thing? Because right now what happens is in our GUI, we're essentially giving the video device over to our like frame data feeder thread. And now what we want to be able to do is we want to be able to like stop that from happening so that we can change the configuration and restart it. So how do we do that? How do we do that? So we have like our eGUI thread who's going to want to like request. He's going to say like, hey, what are my available widths and heights? Which he can probably just get off rip here. So he'll say available sizes is equal to v for L2 device get frame sizes. Okay, so you don't have to worry about that. We don't have to worry about that. We can just present those in the UI always. Available sizes is effect usize like this. Okay. Which means that we're going to go here, available sizes. He doesn't like that for some reason. What's he bitching about? Oh, because these are U32s. I see. Okay. Then on display, I guess we're just going to make like a little drop down. What do they call these guys? Spinners? Is that right? GUI drop down. Combo box. That's what I'm looking for. Combo box. Okay. So here we have a combo box. And what are we going to do in it? We're going to make a value. So we're going to modify, I see. So we modify some value of our selected index and we give it a display name. Right. So here we're going to say selected size is a usize. Our initial selected size will be 0 because we're not thinking about it, but this would be fix pick correct initial size. And here our selected text, I guess we're going to make a string. We're going to convert our thing to a string. So size to string is going to take in a size as a U32 and going to return a string. And what's he going to do? He's going to say format like this, I guess. Size 0, size 1. Easy. Easy. He's going to just take the thing and say X by Y. So selected text is going to be self.available sizes self-selected size like this. And then for each of these, we're going to modify selected size. Okay. And we're going to set these to the value that they are associated with. So 0, 1, 2. I guess we're going to say for I in self.available sizes.len. We're going to add a selectable value at I. And the thing is just going to be size to str of self.available sizes I. Easy. What doesn't it like here? Oh, this needs to borrow as well. Okay. So now what we should see is we should see a drop down above the thing that shows all of the available sizes for us. Where is my window? Are we never getting here? Did we fuck up in our print formats? Is this like failing for some reason? Yeah, there we go. Oh, sick. So here we have all of our available sizes and it's correctly updated, which is nice. And now all we have to do is when we pick one, we should call into our little device driver. So this is where it gets kind of tricky, is because we don't have a reference to the V4L2 device here. So maybe we send a message over to the thread that's polling for frames, and he can like maybe receive a like event request or something. What is this, like UI action maybe is what we'll call it? Sure. That seems reasonable. And so we're gonna have like some enum UI action. And the only thing that he can do right now is change size. And so he's going to pass in a U size that's the index that he wants to change to. We need to rename these from txrx to frame tx and frame rx. And we're going to make another one that's like UI action tx and UI action rx. This guy gets the rx side, this guy gets the tx side, which means that this is the texture rx, and we have UI action tx is a sender of UI action, like this, boom. Okay. And here we have UI action tx, like this, boom. Boom, boom, boom. And now what we just have to do is say, if this thing changed, which I think is something that this guy supports. Show UI returns a inner response, which has a response on it. So if this thing changed, am I on the right spot? No, I'm not. I want it here. So we say, let combo box change is equal to this. And if it changed, we send a UI request of UI action change size to self.selected size. Right? Now this guy will know if let sum UI action is equal to rx.try receive, and this is actually going to be okay, not sum. Match UI action, and we only have one possible thing in here. We are just going to say v4l2 device set frame size to IDX. Cool. And that should probably actually work. I actually don't know if it's going to let us change the size while it's streaming. We'd have to pause the stream and restart it. Nothing's happening, which is unexpected. So here maybe we can say print line changing size, just to make sure that we are in fact getting to that point. No, that's not happening. So why the fuck not? Print line here, combo box changed. Did anything, like, maybe it's just not registering that for some reason. So we just give it a sec. I'm an idiot. I have to actually print something of value here. Turn around. Combo box change like this. So I'm expecting to see false almost all the time until I click on something, then I should see it be true. That's what I expect to see. Oh my god, why does this take so long to compile? A lot of time on the linker. So false, 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 false. We're just never seeing it turn to true, which is kind of interesting. Why the fuck not? combo box. Can we, like, GUI combo box changed? Is that just not valid? This is not firing. Looks like you need to add if click to each thing inside. Yeah, all right. Also store the before value of the enum, then compare after. Yeah, okay, sure. So let prev selected size equals self selected size. And then here, instead of looking for the changed event, we can just say if prev selected size is not equal to self selected size, then we do it like this. Okay, let's try that. Let's try that. So now, sick. Okay, something crashed. That's really good. So here we crashed inside the video for Linux code, and it's saying device or resource busy. So probably what we actually have to do here is, well, we'll just double check. I think that's 456 in v4l2. We're crashing here on setting format, so probably we have to stop and start the stream. Which means that here we start it, and probably there's like a stream off. Hello, vid IOC stream off. Cool. So probably here we have to say stream off. We pause the stream with an ioctl. It says, hey, turn the fuck off right now. Okay. What is video capture buff type here? Oh, we have to specify, hey, fucking stop capturing. Sure. Yeah, stop streaming. Set the format, start streaming. That seems reasonable. I don't know why that wouldn't work. Resource busy still at 458. So that was not sufficient. So vid IOC S format. Can we like just look at where this comes from? Is there... Try format can be set at any time. Okay, but what about... What are like the constraints? Because clearly stopping streaming wasn't enough. So drivers should not return error code unless the type field is valid, blah, blah, blah. Inflexible devices, blah, blah, blah. When IO is already in progress or the resource is not available for other reasons, driver may return busy error code. So is that what I got? Busy? I did. So do I just loop and see if busy was set? Is that reasonable? When I was already in progress or the resource is not available for other reasons. S format stream off. Vid IOC v4l2 change resolution while streaming. v4l2 set format after stream on. This is not helpful. What have we done at this point? We have, when we initialize the device, I wonder if we need to like kill all the buffers that are associated with it. When IO is already in progress or the resource is not available. Well, can we just try, let's do a stupid thing and do a like, no, we shouldn't have anything that's still unqueued. I was gonna say we could just like try this a couple times and see if it fucking fails. While let e is equal to this, like, will that ever resolve? Certainly it won't, right? Certainly doesn't just e busy once and then like give it back to us. Yeah, this is just like hot loops, which makes sense. But then like how am I ever supposed to how am I ever supposed to fix this? iOcto can't be handled because the device is busy. This is typically returned while the device is streaming, and I have to try to change something that would affect the stream, or would require the usage of a hardware resource that is already allocated. Typically stop the stream before retrying. I did that. I stopped the stream. I stopped the stream, man. Okay, I think I need to... My head hurts. I need to take a break, I think. So I think I'll call it there for today. I think we got pretty far, though. We got to the point where, we have our stream showing, or like our webcam showing on screen. We got like color fixed. We got like enumeration of widths and heights. However, we do not have, the ability to switch between them yet. But we're close there. Yeah, I think that's pretty good progress for today. We're at the 2 hour mark. I'm tired. I'm sick, so I want to just like go back to sleep. But otherwise, I think this was like a pretty good stream. Thanks for watching, y'all. If you are watching on Twitch and you like what you saw, there's like a YouTube link in the Twitch description that lets you like catch up on VODs or whatever. If you're watching on YouTube and you want to swing by on Twitch, there should be a Twitch link in the YouTube description. There's GitHub and Discord links in the Twitch description as well. If you want to like see code for stuff. Code for this, I'm not sure if I'll ever post this. I probably will, but probably not today. Yeah, other than that, thanks for watching, guys. I'll catch you on the next one. Bye!